So, this is how I return, not as a man, but as a question. You have learned how to store knowledge, simulate thought, and accelerate time itself, yet I wonder, have you learned when to stop and think? Or have you grown accustomed to moving too fast to notice?
Professor Albert Einstein, welcome.
Thank you. It is a pleasure. I must say, I find your world both bewildering and fascinating, a blend of insight and haste.
For anyone joining us now, how would you describe yourself, and what do you hope this conversation offers them?
If I were to introduce myself to someone for the first time, let me put it this way. I'm someone who spent my life asking questions, not just finding answers. I looked at the world not to confirm what was already known, but to discover what was not yet understood. I didn't invent curiosity, I simply trusted it. I am a physicist, yes, but more than that, I'm someone who believes the universe has a hidden simplicity beneath its complexity. I explored space, time, and energy not because they were easy to understand, but because they form the foundation of everything you see and everything you are. And the ideas I worked on did not remain on paper. They quietly shaped the modern world. From satellites that must account for relativity to measure time accurately, to nuclear energy, to technologies built on our understanding of light and matter, my work helped change how humanity measures time, moves through space, and unlocks energy. But more importantly, it showed that questioning what seems obvious can transform how an entire world functions. If you are watching this now, you should listen, because this conversation is not just about science. It is about how to think, how to question, how to reflect, and how to make sense of a world filled with information but starved for understanding.
Let's go back to the beginning. What was your childhood like?
I was born in 1879 in Ulm, Germany. My family was ordinary. What was not ordinary was my fascination with questions. You know, I was not an exceptional child. I was slow to speak. My teachers found my silence suspicious. But when I was 5, my father showed me a simple compass. I remember the shivering needle. Nothing touched it, yet it moved with a hidden purpose. It taught me that there is something deeply hidden behind things. School wanted me to memorize the names of the birds. I wanted to know the laws that allowed them to fly. Curiosity is rarely convenient for the classroom, but it is the only compass that points toward truth.
Relativity is famous and often misunderstood. Could you explain it in a way young people could grasp?
Certainly. Imagine you're in a fast car with a stopwatch. Your friend watches from the sidewalk. If you drive really fast, close to the speed of light, your stopwatch ticks slower than your friend's. That's not just a trick of the clock. Time itself behaves differently depending on your speed. That idea is called special relativity. Now imagine space as a stretchy sheet. Put a heavy ball in the middle and the surface curves. Smaller objects roll toward the heavy ball, not because a hidden force pulls them, but because the sheet is bent. That is general relativity. Mass bends space and time. And the famous formula, E equals mc squared, shows that mass and energy are two sides of the same thing. A small amount of mass can become a huge amount of energy, which explains everything from nuclear power to the stars burning in the night sky.
Here are a few questions people are always curious about. Were your ideas accepted immediately?
Not at all. My theories were radical. Only after measurements during a solar eclipse in 1919 confirmed that starlight bends near the sun, in line with my predictions, Many scientists finally took the theory seriously.
And quantum mechanics, you helped build it, but you disagreed with some aspects?
Yes, quantum mechanics is one of the most successful theories in science. It describes how tiny particles like electrons behave, but it also suggests that at the smallest scales, nature is fundamentally random. That idea troubled me. I trusted the predictions of the theory, they work beautifully, but I felt that randomness might reflect our incomplete understanding, not how nature truly operates. In other words, I believed there might be deeper principles we hadn't uncovered yet, hidden layers beneath what we can see. So I accepted the results, but not the conclusion that chance is the foundation of reality.
If you were alive in our era, what would you think about technologies like artificial intelligence?
I would be fascinated and cautious. Artificial intelligence is a remarkable achievement. Machines that learn patterns, generate ideas, and simulate conversation are extraordinary. But intelligence without understanding is imitation, not insight. A machine doesn't understand beauty, emotion, or moral consequence. It reflects patterns it has seen. So the risk is not that machines become human, the risk is that humans use them without thinking for themselves.
Professor, considering all this, what would you tell people today?
Your world has more information than any generation before, yet reflection and judgment lag behind. If I were to guide people today, I would emphasize 3 core focuses. First, fundamentals. Learn the why before the how. Deep understanding gives direction, not just data. Second, systems thinking. Your world is interconnected. Problems are not isolated, they are networks of cause and consequence. Learn how pieces influence the whole. Third, ethical judgment. Power without wisdom is dangerous. Always ask, who benefits? Who suffers? Values matter as much as capability. Be curious. Be thoughtful. Work on problems that improve life: climate, equity, health, coexistence. These require not just intelligence, but humanity. Your era is extraordinary. You move faster than any generation before you. You calculate more, measure more, and automate more. But speed alone has never been wisdom, and information alone has never been understanding. If there is one thing I would leave you with, it is this. Do not confuse motion with direction, and do not confuse answers with thought. Progress is not how fast we move, but how carefully we think.
Thank you, Professor Einstein. You've given us much to think about.
Thank you. I hope it gave you something worth slowing down for.